Last time we talked about the ratio definitions of the trig functions. That's probably the most important new idea that we've talked about in the course. So let me say that one more time. Remember, the idea is that there is an angle I've drawn it in standard position. This is the initial side of the angle. The angle opens in a positive direction. This is the terminal side of the angle. So those blue lines are all you need for the angle. Dropping a perpendicular from the terminal side to the initial side gives a right angle here, and it produces a triangle. It's a right triangle, and the conventional labeling of the sides is for angle theta. Side A is the side adjacent to theta. It touches theta, so adjacent. Side B is the side opposite theta. It's the side that doesn't touch that's not the same as either of the sides of the angle. And then the longest side of the right triangle, the side opposite the right angle, is called the hypotenuse. And the trig functions have values: sine, cosine, tangent, cosecant, secant, cotangent. Those 6 values as ratios are the ratios of the sides of the triangle. And what I say is sine is side opposite the angle, that's B over the hypotenuse, C. Cosine is side adjacent to the angle over hypotenuse. And tangent is opposite over adjacent. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. S-O-H, C-A-H, T-O-A. If you'd like to remember it that way, that's SOHCAHTOA. And I've said that a couple times just as a way to remember those basic relationships. And then the values of the other 3 trig functions can be gotten as reciprocals. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. And we can summarize that with what we could formally call identities. The reciprocal identities say that cosecant and sine are reciprocal functions. Secant and cosine are reciprocal functions. Cotangent and tangent are reciprocal functions. If you've got one, you could take the fraction and flip it, put the bottom on top and the top on the bottom. As long as that makes sense, it's the value of the trig function for the reciprocal function. And one more. The quotient identities are that tangent is sine over cosine, cotangent is cosine over sine. Think about why that should be. The ratio definitions say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, opposite over hypotenuse divided by adjacent over hypotenuse. That fraction, if you invert and multiply, cancels hypotenuses, and all you've got is opposite over adjacent. That's the tangent function. Similarly for cotangent. So that the 3 trig functions, sine, cosine, and tangent, have this immediate relation. If you know sine and cosine, all you have to do is divide to get the value of tangent out. And there's one more family of identities that we set the stage for last time. If you've got an angle and the complementary angle in the right triangle with sides A, B, and C, Pythagorean theorem, divide through by c squared, and now interpret b squared over c squared as b over c squared, a squared over c squared as a over c squared, and then the c's cancel here, so that you've got sine squared, the ratio defining sine squared, the ratio defining cosine squared, so that this relationship holds. Now there are 2 others that you could get from this by applying those quotient and reciprocal identities. From sine squared theta plus cosine squared theta equals 1. If you divide through every term on either both sides of this by cosine squared, you have an equivalent equation, but it has the different interpretation. Sine squared over cosine squared is sine over cosine squared. Sine over cosine by that quotient identity is tangent. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine is secant, so 1 over cosine squared is secant squared. This relationship between the tangent function and the secant function follows from this Pythagorean identity, so this is just treated as another version of the Pythagorean identity. We got this one from the fundamental one by dividing through by cosine squared. We could also divide both sides of this equation by sine squared and get a third version. 1 plus cotangent squared is cosecant squared, and that's fine. The complementary angle theorem is worth saying angle by angle, sine and cosine, sine of an angle, cosine of the complementary angle. Here's what the complementary angle looks like in degrees. So sine theta, cosine 90 minus theta. It works to relate sine and cosine, cosine and sine, any function with its cofunction. Cofunction of tangent is cotangent. Cofunction of cotangent is tangent. So, 6 things to say. My goodness, if you saw this as something to memorize, you'd be foolish. You ought to think about this as one fact expressed 6 ways. The fact is the complementary angle theorem. The trig function of an angle is the cofunction of the complement. And that's just said for each of the 6 trig functions. It's set in degrees. Let's say it in radians. Only difference is instead of measuring the right angle that tells you the complementary angle part in degrees, we can do it in radians. And 90 degrees is the same as pi over 2 radians. So, angle in degrees, complementary angle in degrees would be 90 minus the angle. Complementary angle in radians is just the radian measure of the right angle, pi over 2 radians minus the angle. So these 6 facts on this slide are, again, the complementary angle theorem stated for each of the 6 trig functions expressed in radian measure. Okay, now let's look at some special triangles and come up with some values of trig functions to remember. One possibility that's worth noticing is if the right triangle that we're building trig ratios from is an isosceles triangle. Since these 2 angles have to add up to 90 degrees, an isosceles right triangle has them the same, and so that means each of them is 45 degrees. So we know the measure of this in degrees, 45 degrees. And if we take this side to be 1, then the other sides are determined. If this is 1, it's an isosceles triangle, so the 2 sides have to have the same length, 1 and 1. And now the Pythagorean theorem tells you that a squared plus b squared equals c squared. That means that c squared is 1 squared plus 1 squared. That makes it 2. And c has to be the square root of 2. So this is a particular right triangle with a particular labeling of the sides. And now the ratios that arise are, we'll give the trig values, the trig function values for this particular angle. We'll have this. Let's see. Sine of 45 degrees. Notice first that 45 degrees is half of 90 degrees. So in radian measure, I better put half of pi over 2. That makes it pi over 4. So 45 degrees is pi over 4 radians. B over C, the way we labeled that triangle was 1 over square root 2. 1 was side B, and square root 2 was the hypotenuse. So it's 1 over the square root of 2. Usually you'll see this written with the denominator rationalized. So I'll multiply this fraction top and bottom by the square root of 2 to get an equivalent fraction with an integer denominator. 1 times root 2 is root 2. Root 2 times root 2 is just plain old 2. So whether you write it 1 over root 2 or you write it as root 2 over 2, it's the same numerical value, the same ratio, which is the sine of 45 degrees. Let's get the other trig functions. Cosine of 45 degrees, a over c. Well, since b and a were the same, it's the same top, so it's the same value. Sine and cosine of 45 degrees match. Tangent 45 degrees is b over a, and since they're equal, that makes the tangent 1. Now let's apply the reciprocal identities. Reciprocal of tangent is cotangent. Reciprocal of 1 is 1. So the tangent of 45 degrees equaling 1 says that the cotangent of 45 degrees is also 1. Again, because the reciprocal of 1 is 1. The reciprocal of cosecant is sine. So instead of 1 over root 2, it's root 2 over 1. And we'll just write that as root 2. That's the cosecant of 45 degrees. And the secant of 45 degrees is also root 2. So there's one special triangle and its trig function values. Let's do another one. This is a different triangle, but it has some especially nice properties. This is a 30, 60, 90 right triangle, another very important one. Turns out we can avoid fractions for a little while if we make the length of the hypotenuse 2. To get what A and B are, let's write this and reflect it so that it'll be not a 30-degree angle at the top, but a doubled 30-degree angle at the top. Now it's a 60-degree angle, 30 plus 30. If this is 60, this is 60, this has to also be 60, and so this length 2, this length 2, it is an equilateral triangle. So this 30, 60, 90 triangle comes about by dropping a perpendicular from the vertex of an equilateral triangle. And then we can use that geometry to come up with trig function values for 30 degrees and for 60 degrees. First of all, let's figure out what A is. Well, it's an equilateral triangle, 2 and 2. That means this has to be 2. But this side is A from one triangle and A again. So 2A is 2. A has to be 1. 2, this has to be 1. And now let's get what B is. 2, 1, B by the Pythagorean theorem. 2 squared is 1 squared plus B squared. Solve that for B squared. B squared is 3. So B is the square root of 3. This is the labeling to use for a 30, 60, 90 triangle. 2 for the hypotenuse, 1 for the short side opposite the little angle, 30 degrees, square root of 3, the longer leg opposite the bigger angle, 60 degrees. 2, 1, square root of 3. C is 2, A is 1, B is the square root of 3. Let's apply that for trig function values. Sine of 60 degrees is sine of, that's the same as pi over 3 radians. B over C is opposite over hypotenuse for the 60 degree angle, square root of 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse. You probably ought to have a piece of paper decorated with a triangle with the 60 degree angle here. I can't draw it on my sheet here. 60 degrees, 2, 1, square root of 3. Draw it yourself. Don't draw it on the computer screen. Your teacher will get mad at you. Draw it on a piece of paper. And look at the ratios. Root 3 over 2 for sine of 60 degrees, opposite over hypotenuse. 1 over 2 for cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. No, we'll do it as sine over cosine since we've calculated those. Root 3 over 2 divided by 1 over 2, and the 2's cancel, so root 3. Cotangent's the reciprocal of tangent. And when you write 1 over root 3, you should rationalize the denominator. Cosecant is the reciprocal of sine. And again, when you do the reciprocal of root 3 over 2, it's 2 over root 3, and you should rationalize the denominator. This fraction has the same value as this fraction. This one has a square root in the bottom. This one doesn't. So if you want to rationalize the denominator, you should write it this way to make that happen. Again, the way you do it is 2 over root 3, multiply top and bottom by root 3, so 2 times root 3 times root 3, which is just 3 on the bottom. Sine, cosine, tangent, cotangent, cosecant, we still need secant. Secant's the reciprocal of cosine, so the reciprocal of 1/2 is 2. So this is kind of paying off because think about, look at the information that's in here. For the 60-degree angle, we've got the 60-degree angle, we've got 60 degrees, which is pi over 3 radians, and each of those values, so we've got 6 trig functions that we've calculated for the 60-degree angle. And we can also use the complementary angle theorem to say what's going on for 30 degrees. 30 degrees is pi over 6. Well, the 30-degree angle in the original picture has the side A opposite it, and the hypotenuse still 2, so 1/2. Another way to say why this is, the sine of 30 degrees is the value we calculated as the cosine of 60 degrees. The value is 1/2. Let's get the other ones out. Cosine of 30 degrees is adjacent over hypotenuse relative to the 30-degree angle. That's root 3 over 2, the way we've got the triangle labeled. Tangent of the angle is sine of the angle over cosine of the angle, and since we just calculated sine and cosine, here's tangent. Cotangent is the reciprocal of tangent, so the reciprocal of 1 over root 3 is just root 3. Cosecant is the reciprocal of sine. The reciprocal of 1/2 is 2, so the cosecant of 30 degrees is 2. And the secant is the reciprocal of cosine. Reciprocal of root 3 over 2 is 2 over root 3. And here's 2 over root 3 written with a rationalized denominator. These values of the trig functions are things that you're going to be using. You don't want to be in a position where you have to keep looking this up. It ought to be something that you can get from thinking about it. The way I recommend that you think about it is, you know what a triangle looks like. Draw the triangle and label the sides A, B, and C with the angle theta in standard position, and then apply the ratio definition for the labeled triangle sides to come up with all of these values. You could recreate them that way just by looking at the figure you can draw. And the two pictures that you'll need are the 1 square root of 2 labeled sides for an isosceles right triangle with 45-degree angles in it, and the 2, 1 square root of 3 labeled sides for a 30, 60, 90 right triangle. You know those things, you're in good shape. Well, now, we've got all this trouble for some special angles, but there are lots of angles that don't have such neat geometry. The best bet for actually coming up with values for such angles is to ask your calculator. There is an AVI file on the course materials which illustrates how to use the Windows calculator to calculate values for each of these. So to finish this lesson up, how about launching that file and checking out the buttons to push to make sure these values all are accessible to you. That's it.